Lesson 55.A deals with circular permutations. Now, we have to remember just what permutations are first. Permutation is how many different ways can something be arranged. We already know what to do with linear permutations. If I had a question that said, I've got Bob, John, and Mary, so I have 3 students, how many different ways can they be arranged in first, second, and third place? Well, if I looked at it, I say, well, if I have all 3 of them, any 3 of them could come in first, so I put a 3 in the box, and then any 2, and that leaves me with a 2, and because I've got 1 taken out because of the previous, I end up with just 1 in last place, so I got Bob, John, and Mary. And I look at that and say, well, 3, 2, 1, 3 times 2 times 1 equals 6. That's the same as 3 factorial, right? 3 students, 3 factorial. And I would very easily come up with 3 times 2 times 1 is 6. Now, in a circular permutation, this is what's new, is I'm looking at it and saying, well, if I took those same students and I said, well, I could have had Bob or John or Mary come in first. And that's true. Here we go. Bob, John, and Mary. John, Mary, Bob. Mary, Bob, John. The problem is that I've got one of these that are the same on who they're sitting with. It's just rotated, right? Bob was in the top, but I don't care about which is on the top of the circle. I care about who's next to who. So there's really not different ways to do this. There's only 2 different ways to do this. And if I look at it, because who they're sitting next to, if I looked at it and said John's on his right is Mary and on his left is Bob. Well, John on his right is Mary and on his left is Bob. It's the same as this one. It's the same as this one. So our third one is the same as the first, and that kills one of the permutations. So when I look at it, I would say instead of 3, 2, 1, it's 1, 2, 1, because this one and this one are really the same thing. There's no other way to do that. So in other words, if I look at John and he's got Bob on his left, Mary on his right. John, Bob on his left, Mary on his right. John, oh, Mary on his right, Bob on his left. So there's only 2 differences between these, not 6. So when I look at it, I can come up with the same thing. I can realize that instead of saying 3 factorial, I could say 3 minus 1, which is 2 factorial, which is 2, or 1, 2, 1. So I can solve this either by using the permutation, using the factorial, right, which is just 3 minus 1 factorial, and so on, or I can use it by saying 1, 2, 1, and using the boxes, the permutation boxes we've used before. Now, let's look at 55.1. How many ways can 6 items be arranged in a line, and how many ways can 6 items be arranged in a circle? Well, in a linear in a line, I would just say 6 factorial, right? 6, 5, 4, 3, 2, 1. And when I multiply those out, I end up with 720. And if I looked at it, I said, well, there's 6 possibilities in the first box. That leaves me 5 in the second and 4 in the third, and so on. And we would come up with 720 different ways that 6 items can be arranged. But if I take and I make this circular, it, once again, like we showed over here, it kills one of them, making it 6 minus 1 factorial, because this one and this one are the same, because they're touching each other. The end and the beginning become right next to each other, and that kills one of my permutations, making that only one possible way that could be instead of 6, making this the same as 6 minus 1, which is 5 factorial, or 5 times 4 times 3 times 2 times 1, which is 120. It's a really big difference when my end and my beginning come in contact with the number of permutations. So I have 2 ways I can do this. I can either use my permutation boxes and immediately kill the first one, making it a 1 and then going on, or I can use n minus 1 factorial, which is just 6 minus 1, which is 5 factorial, and that's 120, versus 6 factorial, which is 720.